All right, so what I want to do here is factor this problem. Basically, I just want to find all of the roots. The goal is to find all of the zeros of this polynomial function. Okay, so good first step, always check for those common factors. It looks like I have an x in all of these, so I'm going to start by pulling that out. So I can rewrite this p of x. I can rewrite p of x, pulling out this x as x times x to the fourth minus 4x cubed minus 2x squared plus 4x plus 1. Okay, so I actually know right off the bat that 0 is going to be one of my factors. I can set this x equal to 0, so I'm just going to start writing my zeros up here in this top right corner. So my zeros, I know that 0 is going to be one of them. Okay. So I pulled out the x. Now I want to see if I can maybe group this. 1, 2, 3. There's 5 terms. That would be tough. It's not a quadratic. I'm going to jump to the rational root theorem here. So my possible roots are in the form p over q, where p is all these factors of the constant. So it's actually only plus or minus 1. And q is going to be all the factors of this leading coefficient, so plus or minus 1. So my possible rational roots are actually just 1 and negative 1 at this point. Okay, so I'm going to go for a synthetic substitution table. I'll write the top level in red. So my coefficients in descending order here are 1, negative 4, negative 2, 4, and 1. So now what I'm doing is I'm testing my different roots here. What's going to go here are all the possible different roots that could work for this equation, all the different zeros that might work out. So I'm going to test 1 first. So we start by dropping down the 1, and now 1 plus negative 4 is going to give me negative 3. Negative 3 plus negative 2 gives me negative 5. Negative 5 plus 4 gives me negative 1. And now negative 1 plus 1 gives me 0. So I got that remainder of 0, which is awesome. So I can now rewrite. Remember, I'm just rewriting this big polynomial. So now I can actually rewrite it. Don't forget this x. So I'm rewriting it as x times x minus 1. Remember, x minus a was 1, times my quotient. So this is my remainder of 0. So negative 1 will be my constant. Negative 5 will be my x term. Negative 3 will be x squared. And 1 will be x to the third. So I can rewrite, again, as the divisor times the quotient. So now I have x times x minus 1 times x cubed minus 3x squared. So x cubed minus 3x squared minus 5x minus 1. So now I want to see if I can group this again. It's actually not going to work out really well trying to group this, so I'm probably going to test the rational root theorem again. So my p over q will be the same. My constant